Okay, so we're going to do two things today. We're going to talk about unit tests. And this is going to apply directly to your homework assignment that's due tonight because you have to do this vector stuff, right? And so I want to demo to you what a unit test is. And then this is a very important topic in software engineering. And so we'll show you this unit test facility that we have. And then second, there is also a written assignment, and the written assignment should be reviewed. Did you all do statement execution counts in computer science too? So it's statement execution counts. Okay, so let me go ahead and demo the unit test, show you how that works, and then we'll see if there's any questions about the implementation project that's due tonight. Now, the unit tests that's a standard terminology. A unit test is, what it does is it tests a unit of your code, normally a single function. You know, when you run a program, you know that if you run a program and you don't compile it and test it and you just hand it in, you know it probably might not even compile. I mean, there's just so many things that can go wrong. So testing is a huge topic in software engineering. There are actually test engineers. You can spend your life testing. You know, I mean, it's a position that you can have. So it's a very important topic. There's lots of research done on it, and it's super important. And most computing environments have facilities for unit testing. Unit tests are built into the Java platform. And in searching around for a unit test for C++, I tried different open source solutions and finally decided that we should just use our own unit test system that I just built into this DP4DS distribution. And so here in figure 2.25 is a screenshot of what a unit test looks like for vector T. Okay, so we have, so you see on the first line we have I10-0WCS, and then on the second line we have I20-0WCS. And I don't know if you remember from our demo last time, but what do you suppose that represents? That I10-0WCS? Well, if you run the vector T project, those are the letters that you can type to test the software. So let's just remember that the first couple of rows, I10-0WCS, I20-0WCS, right? So here, let's do a demo, show you how this works. Okay, so here's our project, and the first thing we'll do is we'll run vector T. So here we right click and do run. And so here we're running vector T. And now what was on that first line of the slide? I. It was I. So look, we press I, insert what in it. Now what was the second item on that? It was 10, right? And then what was the third one? 0. And then there were some letters, right?
WCS.
W. C. Was it C?
Yes.
And then what? S? All right, and look, all all that text that was in our unit test driver, basically what it does is it's what you could type here on the console thing to test the program. You see what I mean? But look. So here is our our vector T project, and now check this out. If you go over to Files and you look under vector T, there is a folder called Unit Tests, and if we double click on Unit Insert, this brings up this unit test, and look, it has that text that was from the slide right up here. And so what you can do is, instead of typing that manually, look what you can do. You can take this and copy it, right? You can copy this, and then you can go back here to vector t, and you can run it. All right. And now, instead of having to type all that stuff, check this out. You can just paste it and press return, and voila! And check this out, you guys. If we come back up here to the top, in your unit test file, if you copy and paste this in, this tells you what you should get. So see, it should be 10, the capacity is 1, the size is 1, 20, 10, the capacity is 2, the size is 2, and here it is. 10, the capacity is 1, the size is 1, 2010, the capacity is 2, the size is 2, etc. And you can check this all the way down to the end. So the very last one should be 30, 40, 60, 20, 10, 50, the capacity is 8, the size is 6. You can check all those here, and here it is. 30, 40, 60, 20, 10, 50, the capacity is 8, the size is 6. Pretty neat, huh? Okay, end of demo. Okay, so that's the demo. And so from now on, what you should do is these unit tests files are what I'm going to use, what the grader's going to use to run your projects. So if you want to know if your software is correct and will pass the test, all you got to do is run the unit test. Isn't that neat? That's a super valuable tool, and from now on you should just always use those unit tests by copying and pasting. Make sure that you copy the text from the unit test file and then paste it into copy the right thing and paste it in. All right, so that's available for you. Okay, so now, are there any questions, specific questions about this particular assignment? Yeah. Yeah.
If it's saying that it's having trouble, it cannot find async.hpp.
Yeah, usually the reason that is because you have to go into the include file and include /async. Are you with me? Right click on your project properties. Yeah, you're getting some help from your neighbor here, so that's good. See, actually, since you asked that question, let me just state what it is that's happening. In your code, when you say #include and you give a file, because you want that file, the source of that file, the compiler to be able to run through the source of that file when it compiles your program, the system needs to know where to find the file. If you don't put it in that include list, then the system does not know where to look. I mean, after all, you've got hundreds or maybe thousands of files on your computer. You can't expect it to search through the whole disk of the computer. So what you're doing there for the development in the IDE is you're telling the IDE where to go to look to find that code, and it's just saying I can't find it. That's what that message means. So the next topic is going to be analysis of algorithms. Now, we're starting here. What we're going to do here in Chapter 3 is, up until now, we have got a collection of programming tools. What we need now is a collection of analysis tools. All right? So this chapter is not about programming. This chapter is about how to analyze the performance of an algorithm. And it's going to use some techniques from our formal methods and our discrete structures courses. Now, and the whole idea is to be able to analyze how fast a program will run, because after all, that's what the user wants. The user, when the user buys a piece of software that you write for him or her, that the user wants the program to run fast. So we need to be able to understand what makes some algorithms run fast and what makes some algorithms run slow. So we need to quantify it. So that's the topic, analysis of algorithms. And the first section of this chapter, section 3.1, is about iterative algorithms. And by iterative algorithms, we mean loops. So like for loops. All right? So what we're going to do is we're going to run through a couple of examples to see how to analyze these algorithms. Now, this first example that we're going to look at is called largest last. Now, you've probably seen this before, but you did sorting algorithms, right? In your programming class. So this largest last is a little algorithm that goes through all the elements of an array and finds the largest one and puts it at the end. Okay, so it's called largest last. And here, let's take a look. It says, notice here on this slide that the lines are numbered. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Some of these lines are executable, other ones are not. The ones that are numbers, like line 7 is next to the brace, well, the brace doesn't execute. Okay, so that's not an executable line. Nor is the template line, line 1. But the assignment statement, int index of max gets 0, that does execute. That is an executable statement. Is everybody clear? So let's just take a look at this code and see what it does. It says int index of max gets 0, and then for j gets 1, j less than len, which is length, j plus plus, right? So it starts, and then it says if a sub index of max is less than a sub j, then on line 6, index of max gets j. Are you with me? So it's comparing it. You've seen this algorithm before, I'm sure, right? And so it's saving the index of max, and then outside the for loop, it does temp gets a sub length minus 1, a sub length minus 1 gets a sub index of max, a sub index of max gets temp. So what does that do? What is a sub length minus 1? That's the last values, so that swaps them. All right. So here's a little example of how the code works. So suppose the initial list is 30, 20, 70, 85, 40, 10, indexed from 0 up to 5. And what happens is, so here on this slide, we're going to say, we're going to use the letter M for index of max. Are you with me? So we will frequently, in analysis, we'll just abbreviate those variables with single letter names, you know. We'll do that a lot. So, and then remember that line, index of max gets 0, so that's the M gets 0, so that makes M point to sub 0, the array sub 0, right? And then it was, remember what the next line was? For j gets 1, right? So j gets 1, so there's the j gets 1. And now there's this dividing line here between, just to the left of j. And then remember with that if statement, what did that if statement do? Yeah, so the 30 is not greater than the 20, so we skipped the body of the if and we just did j plus plus. Are you with me? And then next was, the next time through, when it was j plus plus, the next time through it compared the 30 with the 70. This time the 70 is bigger than the 30, this time the 70 is bigger than the 30, so what happens? M gets j. So now instead of M being 0, what is it? 2, the index. Is everybody clear? It's the index. All right, and then j plus plus, and then for part G, in part G, then M gets j because 85 is bigger than the 70, and then j plus plus, and then j plus plus again. M doesn't get, 40 is not bigger than 85, so j plus plus again. And now at the end, now we have found the largest one. So what's the index of the largest one? 3. So now, and then we do the swap, the 3 statements, and we swap them, so that makes the largest last. Is everybody good? Now here's what we need to be able to do. We need to be able, and here's a skill, and I have found that people are frequently rusty on how to do this. So let's relearn it if we have to. We need to be able to count how many times each one of those statements executes. Right? Now obviously it's going to depend on the value of length, len. Are you with me? Okay? So actually I think what we're going to do is let's go around the room just so that everybody gets a heads up. And if you want to pass, if you can't figure it out, relatively quickly, just say pass and we'll just go on to the next person, all right? Okay, so now can you tell me, starting here on the front row on this end, can you tell me if len has the value 2, len has the value 2, how many times does the statement on line 3, index of max get 0, how many times does that execute?
Once.
That's good. It executes 1 time. Okay, next. How many times does for int j gets 1, j less than len, j less than j plus plus, how many times does that execute? If length is 2, so if length is 2, this is saying for int j gets 1, j less than 2, j plus plus, right? So can you tell me how many times does line 4 execute? Yeah, that's just once is what a lot of people say, but the problem is it executes once and it goes through the loop, but then when it gets back up, it fails. It executes one more time for the fail. That's an important point. So therefore, you want to change your answer? 2. Is everybody clear? All right. Now, how many times does this if statement execute on line 5? I'll give you a multiple choice. Once or twice?
Once.
Oh, good. It's once. And now here's the thing. We are doing, notice down here on the lower left of the table, we're doing best case. Now, what's the difference between best case and worst case in this little algorithm? When does the best case occur and when does the worst case? Worst case means what? Long execution, which means what? Maximum possible number of executions. What would happen for the worst case on line 6? It would what?
For the worst case?
For the worst case, what would it do?
It would execute once.
Well, it would execute each time through the loop. Every time through the loop. Right. But in the best case, it would what? It'll never execute. So what is the best case for this? So
0.
0. Is everybody clear on that? All right. Now, lines 7 and 8 don't execute because they're just braces. Okay? And now, what about line 9? Once, because it's outside the loop. What about line 10? Once. And what is the next one? Once. Okay? So now, and so now you have it easy. What's 1 plus 2 plus 1 plus 1 plus 1 plus 1?
7.
That was, you lucked out. All right, now how about if length is 3? How many times does line 3 execute? Once, because it's outside the loop. Now, 3. Now, okay. Next. Twice?
Yeah.
Yes. 3, that 3 was the test, it was because of the test, but then once in the loop it's twice. Okay. Next.
So are we at the index of max?
Yeah, line 6. Best case.
0.
Yes. All right, okay.
Once.
Once because it's outside the loop, and now we'll go to the back row. Once. Next. Once. And now, what is 1 plus 3 plus 2 plus 1 plus 1 plus 1? Can you add all that up?
1.
Okay, 9. All right? Now comes what happens if len is n in general. Okay, so here comes the harder part. Okay, so next. Okay, once. Okay, so what about line 4? Next. N times. Now, how about line 5? N minus 1. And how about line 6? You guys are doing good. 0, but oh, you got it easy, in best case. Okay, next. Next.
Oh, yeah, once.
Once. Now, what is 1 plus n minus 1 plus 0 plus 1 plus 1 plus 1? 2n plus 3. Are we good? Okay. 2n plus 3. Is everybody clear on how we did that? Yeah, question? But I mean, the third column is a generalization of the first two. Yeah. It's in general. Okay. And usually the way to do this is to see the pattern, you know. All right. So, okay, so that's 2n plus 3. Now, what about the, I forget who is last. Whose turn is it? Okay. So now, what about the worst case? What about the worst case? In the worst case, what would we have on line 6? And the best case, line 6 was 0 and 0 and 0. But in the worst case, line 6 would execute the same number of times as line 5. So what would that row on 6 be in the worst case?
For length 2?
Well, for length 2, 3, and then n.
Okay, 1, 2, and then n minus 1.
Yes. Okay, so that would be 1, 2, and n minus 1. And then if you added, and then I just did the math here, if you add 1 plus n minus 1 plus n minus 1 plus 1 plus 1 plus 1, that's 3n plus 2. All right, so now you guys, we have an important conclusion here. Our conclusion is that the execution time is linear in n. Is everybody clear on that? That means that if you double n, you roughly do what?
Double the execution.
Double the execution time, right? So if you have an array, if you're trying to find the largest last of an array that's twice as big, it's going to take you roughly what? Twice as long. Now, is everybody clear on that? That's what that means. That's our conclusion, yeah.
So do we just kind of assume that like the 2 or 3, the plus 2 plus 3 times that it runs is kind of irrelevant relative to n?
Yeah, now you might, that was a good question. The question is, what about the 3, the coefficient of n, and then the plus 2? Now, you probably remember from formal methods that we had asymptotic analysis where we saw how those didn't matter, and we are going to get to that and review that in a later section of this chapter. All right? Is everybody good? Okay, so now that was a single loop. Now it gets a little bit more tricky if we're talking about a nested loop, okay? So with a nested loop, what happens is you have a loop inside of a loop. And so here the counting is a little bit more involved. So now, did you guys do selection sort? So this is the code for the selection sort, only here we have a templatized class, it's template class T. By the way, what is that capital T? That is like the what parameter for the template? That's kind of like the formal parameter, and when you actually set it up, that T could either be like double if you're sorting doubles, or int if you're sorting ints, or even string if you're sorting in alphabetic order, So, and so this is selection sort, and so we're assuming that A is an array, and it has length len, okay? And now let's take a look at what the code does for this selection sort. In line 3, it's for int k gets length k greater than 1, k minus minus. So now k is starting off to be big, and it's getting smaller. And what's the whole idea? It's starting out big, and what's it going to do when it's big? It's going to find the what? What does the code inside the loop look like? It looks like, index of max for int j gets 1, blah, blah, blah. It looks like what? Largest last. So it is the code for largest last. So it'll go find the largest and do what? Put it at last. And then it'll go down by 1, and then it'll find the largest here. It will select the largest and put it last. That's why it's called a selection sort. And then it will select the largest and put it there, and select and put it. So k is the control variable for the outer loop, and j is the control variable for the inner loop. So it starts with the whole one, and it finds the largest, and it puts it last. But when it finds the largest, it starts at the first to find the largest. Okay. But it's up to k. Notice the test for int j gets 1, j less than k, j plus plus. So this is going to be a little trickier. So here is here's a sequence of snapshots of the state of the execution that shows what it does in figure 3.3. Let's suppose that our initial list is 30, 20, 70, 85, 40, 10. And so it has a length of 6. All right? So what's it going to compare now? What's it going to do on the very first step? It's going to go through, and now what's the largest one? 85. And so what's it going to do with it? It's going to swap with 10, put it last. Okay, so when k equals 6, so k starts off to be 6. When k is 6, it swaps the 85 and the 10. Then what will happen? When k equals 5, what will happen?
70 and 40.
70 and 40. And notice that, and then when k is 4, what will happen?
10 and 40.
10 and 40, right? And notice that each time you go through, the shaded part of the array is sorted. That's one of the invariants, is that the part on the right is sorted. And then it'll do what when k is 3?
Swap 20, 30,
Swap which?
30 and 10.
Oh, 30, I thought I heard a 20 there. Yeah, 30 and 10. And then what?
20.
Yeah, well, it'll swap the 20, and it will literally swap the 20 and the 20. Are you with me? I mean, that's literally what it will do, but, you know, it'll do temp gets 20, 20 gets 10, 20, you know. So, but that's literally what, and then when there's only one element there at the end, there's no more swapping. It doesn't bother to swap 10 with itself. All right, does everybody see? Okay, now, now this is what you have to do for tonight. You have to, and I'm giving you an array, a nested loop, and you need to go through and be able to do this mathematical computation of how to count. Yeah, question?
Like format-wise, or should we just like create our own like little table? With
Sure. Yeah.
Okay.
Yeah. I mean, however you want to do it.
Yeah, and then the main focus is the nth case. Right?
Yes.
So then the total part. Is
Yes. Yeah. I don't think I bothered to ask you for what the individual numbers were, but just so long as you. Yeah. Some people can do this. Some people can do this without doing the specific cases. You can just say, oh, well, this is in general. It's a little. I find it's a little more straightforward to see the pattern and then generalize. Okay, so here it is. They're numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and the executable statements are 3, 4, 5, 6, 7, 10, 11, and 12. Where did we end? Who was last? Yeah, you think you're up? Okay, good for you to volunteer or to. All right, so now so let's suppose that len is 2, the length is 2, and line 3 is 4 int. So this is like saying 4 int k gets 2, k greater than 1, k minus minus. So for k gets 2, k greater than 1. So 2 is greater than 1. K minus minus, so 2 times. Good. Okay, next. Now we're inside the loop. This is int index of max gets 0. So 1. Good. Now, next. Now, this is where it gets tricky. Because what's happening here? What did we, when we hit this, how many times did we go through the loop? We go through the loop, we're going through the outer loop once with the value of k of being what? What's the value of k? It's 2. So this is saying for int j gets 1, j less than 2. So how many times? Twice. Okay. And now we are inside the loop. So how many times for statement 6?
1.
Good. Okay, and now how about statement 10?
10.
Oh, sorry, it was 7. Wait. Wait. Oh, best case. 0. You lucked out on that one. Okay.
10. Or 1. Sorry.
Line 10. 1.
Yes.
1. 1. What's, 2 plus 1 plus 2 plus 1 plus 1 plus 1 plus 1. Yes, 9. Good. Okay. Now, next. If len is 3, if the length is 3, then this is saying int on line 3 is int k gets what? 3, k greater than 1. So 3. All right. 2. All right. Now, wait a minute. This one, now here's where it gets tricky. Say it again. Is it 3? No. Now let's take a look at line 5. Let's take a look at line 5. No, as we say here, it's 2 plus 3. Now why is it 2 plus 3? Now here's where it gets tricky. Why is it 2 plus 3? Because the first time we go through the outer loop, what's the value of k?
3.
It's 3, right? So the first time we go through the loop, it's saying what? For int j gets 1, j less than what? Yes, and so how many times is that? How many times does that execute? 3 times. And then the next time it goes through the loop, what's the value of k? 2. So at that time through the loop, how many times does it execute? Twice. So don't write down 5, write down 2 plus 3. Are you with me? Did you see how that worked? Okay, so now what about the next one? What about line 6? Instead of 2 plus 3, what about line 6 doesn't have that extra test. So what is it? You want to pass? This is, yeah, this.
It's 2.
Nope. You want to, next?
1 plus 2.
Yes, it's 1 plus 2. It's 1, it's 2 the first time through the loop, and then it's 1. Do you see how that worked? It's 1 plus 2. All right, so next, oh, you got it easy.
0.
0. Now next, 2, 2, and 2. All right, and so now what is 3 plus 2 plus 2 plus 3 plus 1 plus 2 plus 0 plus 2 plus 2 plus 2? You get all that up?
19?
19. Okay, now when length is n, what is it? What is line 3?
Just n.
N. N minus 1. Next, yeah.
Isn't it?
Now it's going to be dot, dot, dot. It's going to be something plus dot, dot, dot plus something.
It's like 2 plus 3 plus dot dot dot
Plus what?
n.
2 plus 3 plus dot, dot, dot plus n. Is everybody clear? Now what about the next one?
1 plus 2 plus dot
Dot, dot, dot. Plus, no, you were close but no cigar. The last one was not quite right. It's going to be 1 plus 2 plus dot, dot, dot plus, what's the last one? Yeah, plus n minus 1. Next?
0.
0. You get it easy. Next?
N minus 1.
N minus 1. Next?
N minus 1.
N minus 1. Next? N minus 1. Good. And now what is m? Oh. Now what do we have to do? Now you guys, do you guys remember this one? Do you remember? Do you remember? Now we did this in formal methods, in discrete. Do you remember the sum of all? Do you remember the sum of all the integers? 1 plus 2 plus 3 plus dot 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 plus n. Do you remember what that was? You should know this because this comes up all the time in analysis of algorithms. Do you remember what this is? The sum of the first n numbers? No. Yes, it's n times n plus 1 over 2. You need to know this. I won't give you this on the exam if you have to do a statement execution count. All right? So now my question is, if that's what that is, what is 2 plus 3 plus dot 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 plus n? See, my question is, what is 2 plus 3 plus dot 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 plus n?
Is it n plus 1 times n?
It's just 1 less.
Okay.
It's 1 less. It's 1 less. Yes, that minus 1. Yeah, it's that minus 1. Are you with me? Is everybody clear on that? It's that minus 1. Okay? Is everybody clear? Now, let's write this out with n squared. How many n squares do we have in this expression? It's something n squared plus something n plus something. Look, it's a half n squared plus a half n minus 1. Are you with me? Because it's n squared minus n, or the whole thing divided by 2. Right? N squared plus n, the whole thing divided by 2, and then minus 1. Right? Is everybody clear? And now what about the other one? What about line 6? What's 1 plus 2 plus dot 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 plus n minus 1?
The same.
Well, I mean, using this same formula, the last one was n, right? So what if the last one is n minus 1? Well, it's the same formula with n replaced by what? N minus 1. So what is it? N minus 1 times what? Divided by 2. Okay. So this is n minus 1 times n over 2. And so if you work this out, it's this, all right? 1/2 n squared minus 1/2 n. And so if you work that all out, it turns out to be n squared plus 5n minus 5. Now what happens? That's the best case. What happens in the worst case? What's line 7, everybody? Same as what?
Same as lines.
Same as 6. Same as line 6, right? So you work that out, and you get 3/2 n squared. So what is our conclusion? It's not linear. What is it? More specific. It's not a power of 2. It's quadratic. It's quadratic. Conclusion, the execution time is quadratic in n. All right, good deal. See you all on Monday. Have a great weekend. After you hand in your homework tonight.